When the significant value is less than 0.05, then we will say there is a difference, simple. When there is a significant value is less than 0.05, we will say there is a difference. When there is a difference, you should not stop. We should compare the means, which is having more mean, which is having the less mean. We have to compare and write. So before performing this comparing the means, you should compare the variance first. That is the homogeneity test, otherwise called a Levin's test. So in independent sample t-test also, we are looking at the Levins to find out whether there is a equal variance or unequal variance. That is what we have done. So when the homogeneity test is 0.000, which is less than 0.05, then we will say they are heterogeneous. They are heterogeneous. Then we cannot apply directly the ANOVA, we have to apply Wells test. Right. When you apply the Wells test, so to compare the means, we have to go for a post hoc equal variance not assumed Tanner test. Tanner test, right? So this is what we have seen. So, but the ANOVA is a very, very big family. It will take minimum 3 days, 6 hours it will take. But I have taken only 2 hours. We have many more things to study there. So that we will come up tomorrow or day after tomorrow. So today we will go to the next one by taking 2 variable metric. We are going to take 2 variable, both are metric in nature. Okay, then let us see how to make analysis. So I have already told madam, when the both variables are metric, what to do, madam? Nandini madam. Nandini madam. Nandini madam. When both variables are metric, what to do, madam? Madam is not there. Huh? Okay. Some people are writing, right? We have to do correlation, right? So I am going to the correlation folder. Sir, Nandini madam is not there, sir.
Is there, sir? I have some problem.
But not responding.
Nandini ma'am, one minute, sir.
Okay, so now I'll take one data set. So now I have one data set, right? So which contains, okay, both are scale variable. Okay, here none, here none, right? So which means it is a metric variable, right? None. So which is a metric variable, this is also metric variable. What is the variable name? Variable name is, okay, variable name is sales in 1000 and fuel efficiency, right? Sale in 1000 and fuel efficiency, right? So it is the car sales. Okay, so what is the logic is, generally people will say, so mileage, that is the fuel efficiency, mileage per gallon, right? So when there is fuel efficiency, or when the particular car is giving more mileage, then we will say the sale will be more.
Excuse me, sir.
Yes, madam.
Excuse me, sir. This is Lokeshwari, sir. The screen is not visible, sir.
அந்த அவர் சாரும் சொல்ல மாட்டாரு, நந்தினி மேடமும் they are not telling.
Sir, I'm here due to some problem. I was not able to talk, sir. That is unmute madadika.
Not able to.
Okay, so now I have to repeat whatever I have done for 5 minutes, it will become waste. One is time waste, another is I have to repeat. Okay. So now I think the data set is some people are always entering there, disturbing my view. So that is number one. Okay. So now let me tell again. I have one data set by name car sales. So it contains two variable. Okay. So one is sale in 1000, another is fuel efficiency. Two variables. Both are having none, which means no values are there, no categories are there, which means they are metric variable. So here also scale we have put, right? Here also, right? We cannot count. So 16, 1, say 13, 39 like that. All are different variable values. So we cannot count the frequency. We can find out only the mean. So both are metric variable. Okay, so now we have taken two metric variable. Here, what we have taken is, we have taken the sales of particular car and the mileage of that particular car. The logic is, when the mileage increases, the sales also will increase. So that is the logic, right? That is what the correlation is. What is the correlation means? Whether mileage is related to car sales. Mileage is related to car sales. Right. So we are trying to find out whether they are related. Whether they are related. Mileage and car sales are related. So our null hypothesis is, yes, madam.
Yes,
What is our null hypothesis?
when null hypothesis is rejected, there is no difference.
What is null hypothesis, madam? Here
None.
we are trying
There
to
is no
find out.
relationship.
There is no
There is no
relation. Okay. So we are trying to find, madam. Please speak here, madam. Don't talk about the old things, sir.
Sir. Okay, sir.
Okay. So we are trying to find out the relation,
Okay.
whether these are related. So our null hypothesis, there is no relation. So framing null hypothesis is not at all difficult, right? Not at all difficult if you know what is the purpose. What is the purpose of that test? We are trying to find out relation. So we will say there is no relation. Simple. Okay. So that is the null hypothesis. Alternate hypothesis, there is a relationship, right? Very good. So now both are metric variable. So I have to go for a correlation, right? Now let me go to analyze. Okay, both are metric variable, right? So I can use correlation, right? The null hypothesis, they are not related, right? So two variables are not related, right? So now this we have seen, compare means we have seen. This general linear model I have to teach. I will take up tomorrow, right? I will take up tomorrow. Now I am going for correlate. I am going for correlate. So correlate, right? Correlate. Okay. So then we will put bivariate. Bivariate, right? Bivariate. So bivariate means two. Bivariate means two. So whenever we say relation, it is relationship between two variables, right? Bivariate. So let us take up both variable, right? We can use shift key, control key, okay, control A, all we can use. So I have put both variables, right? let me say okay, simple. Let me say okay. So now, okay, so now Nandini madam will tell, right?
Sir, actually in the screen there is a pixel, sir. Some boxes is coming. Actually, it is not visible properly for me. I don't know about others. Is everybody facing the same problem or only me?
Yes, ma'am. Yes, ma'am. There is a black box.
Yes, sir. That is pixel.
Please check it, sir.
Yes, sir?
No, sir. There is a black boxes. Oh, yes. There is a full box now.
It is completely blank.
Where? Square black box.
Black screen. It is.
Now off, sir. Okay.
Now, is it visible or not, sir?
So that correlation
It's
box
visible, sir.
is
Correlation
right
screen
now,
is
but
visible. No, no
also
problem.
there is a black screen, sir. Little bit of black screen in the top.
Yes,
Can you show
madam?
one? Can I show one photo in the WhatsApp, sir?
Yes, sir? Any, no. Whether it is visible to you or not, sir.
Sir, right now correlation box is visible. At the
Hmm.
same time in the screen there is a problem that black color box is off, slide is not visible properly.
50% of the slide is closed by black screen.
Yes, this black you are telling, right?
Yes,
sir.
yes,
Yes,
yes.
sir.
Huh?
Yes,
Yes,
sir.
sir.
That is, I cannot do anything, sir, madam. Every time people are entering, so this black screen is coming. So, okay, so it is disturbing.
Continue,
That
sir.
is one. Then this black screen will be there, no?
Yes, yes. Oh, no,
Ah, yes.
it's close. Continue, sir.
See, we have put in the middle is, right? So this, if I put it on the top, these menus are not visible, right?
Oh, okay, sir. Continue, sir.
Madam, is it okay or not okay, madam?
It's not okay, sir. Why? Because again, it's coming and going sometimes not able to see properly. It's not visible. Now it is okay, sir. Correlation box is visible.
Okay. Okay, so you ask others also, madam, is there any
Yes,
problem?
sir. Okay, sir. Okay, sir. Continue, sir. No problem.
Okay. So now this, okay, correlation table is visible, right? So now what is your interpretation, madam? Or Sivakumar sir or somebody you put madam? ஒரு மேடம் கொஸ்டின் கேட்டாங்களே அந்த மேடம் சரிதா மேடம், ரைட்? அந்த சரிதா மேடத்தை பிடிங்க. ஹலோ
Sarita, ma'am. Sir is calling. No, sir. Sarita, ma'am. Please raise your hand. Sorry. No, sir. She's not there.
Okay. So now, madam Nandini madam, what do you see, madam? What do you see? Sir, நீங்க இல்லன்னா நீங்க சொல்லுங்க. Somebody you please tell. Okay.
Sir, more than.
No, you first you have to tell the significant value, sir.
Yes, sir.
Then only you have to tell whether it is more or less. First you have to
It's
tell.
more than
0.8.
0.05.
No.
0.83.
See, first you have to tell the value, right? So then only people will understand which value you are telling. First you tell the value, then whether it is less, greater, or you tell later. Yeah, first.
Okay. 0.837.
0.83. Significant value is 0.83.
0.837.
Okay, this value you are telling. Yeah. Now.
Yes, sir.
More than.
More than.
Hmm.
Then there is a
It is
relation.
more than 0.05. Hmm.
Reject the null hypothesis.
Yes, madam.
Reject the null hypothesis.
No, sir. Accept it.
Sorry. Accept the null hypothesis.
Madam, please read and come, madam. Please read. I request you to read, right? Otherwise, it will be a wastage of time. No one is coming also, right? No one also coming, right? So it is a very, very small thing. Okay, you have to take it to the mind. Okay, so this is very simple thing. Greater than 0.05 is accept. Less than 0.5 means reject. Okay. So now less than it is 0.837, which is greater than 0.05, which means we have to accept the null hypothesis. Null hypothesis is there is no relationship, right?
Yes,
So
sir.
which means there is no relationship. That's all. Is it okay or not okay?
Okay, sir.
Okay. So there is no relationship, right? Actually, right? Actually, you should not say we have to accept the null hypothesis, right? Technically, you have to write differently, right? How differently is we do not have evidence to reject the null hypothesis. So instead of saying we are accepting, we do not have evidence, right? We do not have enough evidence to reject. That is the way you have to write, right? Right. See, the idea is why. Idea is why, right? So now, okay. So my null hypothesis is there is no relationship, right?
Yes, sir.
What do you mean by there is no relationship is, okay, that I will come later. I will come later. Okay, so I will come later. Okay, very good. So now I will take up one more data set. Okay. Okay, so I'm taking one more data set. The data set name is,
The screen is not visible, sir.
now I will come. I'm coming. I'm coming. I'm coming, madam. Okay. Now screen is visible.
Yes, sir.
Okay. So now here we can say, okay, so we can see two variable by name Z score and H score. So none, right? None. So it is a metric variable. Here also scale, so metric variable. Here also all values are different. So we cannot count how many ones, how many twos, because each values are different. So we can find out only the mean. So both are metric variable, right? When both are metric variable, we can find out the correlation, right? So now what is the correlation? The relationship between two variables. So we are trying to find out relationship between Z score and the H score, right? Okay, what is this ZH? We will come later. We will try to find out the relationship between Z and the H. Okay, analyze,
Analyze,
correlate,
correlate, bivariate.
bivariate, right? Bivariate. So I can use shift key or I can use control key. I can use control A key. Anything I can use. Okay, so now the output is visible, right? Madam, output is visible.
0.000, sir.
0.000, very good.
It is less than 0.05.
Mm,
Reject the null hypothesis.
mm.
There is a no.
Relationship.
There is a relationship, right? So
Yes,
no
sir.
relationship is rejected, which means there is a relationship, right? Okay.
Yes,
Okay. Now, okay. Yeah, you need not have okay this much trouble, right? So let me tell from the beginning. I am telling a simple way also. Very simple way also. I am telling. Okay, you need not trouble, right? Even if you feel even these small things is having difficulty for you. So let me put straight away. Right? If the significant value is less than 0.05, let us say there is a relationship, simple matter. We are trying to find out relationship. If it is less than 0.05, there is a relationship. In the ANOVA, there is a difference, right? In the chi-square, there is an association. I have told you yesterday also. Okay, so you need not confuse because see, tomorrow I will take up factorial ANOVA and other things. I will be running many times ANOVA. I will be running many times. So every time I cannot wait this much time. Okay, so straight away I will say, I will show the significant value. There is a difference. There is a difference. There is no difference. Like that I will go.
okay.
So at that time you should not ask me how you are telling, sir. Okay, so you should not get planned. So now my significant value is less than 0.05, there is a relationship symbol, right? If it is ANOVA and compare means there is a difference. Chi-square, there is an association. For regression, there is an influence. So four words, association, difference, relation, influence. Madam, please repeat the four words, madam.
Association, relationship,
Yes.
another.
Hello?
Sir, am I audible, sir?
Yeah, audible. Proceed. I could hear you.
Relationship, difference, only these two I can.
Okay, so now I will tell again. Right? Okay, so for chi-square, we use the word association.
Sir.
For compare means we use the word difference. Now we are using the word relation. Right? In regression, we will use the word influence. Right? When it is less than 0.05, there is an association, there is a difference, there is a relation, there is an influence. Hello?
Sir.
Tell again, madam.
For chi-square, there is association and difference, relation, influence.
When, madam, when?
When it is ANOVA, there is a relation.
No, when we will say there is a relation,
Oh. Then there is a, when we reject the null hypothesis.
In correlation,
that and all you need not tell, madam.
Okay.
Okay, when the significant value is less than 0.05, that's all, madam.
Okay, sir.
Okay, so why you are telling unnecessarily Thirupa again reject the null hypothesis, all this thing, right? So that is the trouble. That is the trouble. Why do you go for a trouble again?
Okay, sir.
Okay, don't go for trouble, right? When the significant value is less than 0.05, we will say this one. Is it okay now or not okay?
Okay, sir.
Very good. So I feel I am troubling too much this, madam. That no one is coming. What to do? All the people are safely shifting. Okay. Okay. So see, yeah, when they think they are safely sitting.
sir, one more is coming, sir. One more is coming.
Who?
Oh, that is Arinakshi.
Yes, sir. Yes, sir.
Arinakshi. Arinakshi.
Your friend, eh?
No,
Okay.
sir.
New friend.
Okay, sir. Okay, let us not go other way, sir, because you should go in one tempo, sir. If I
one
go
tempo.
outside,
Oh, this is better. Okay.
yeah, I should go in one tempo, sir. If I talk other things, my tempo will get exhausted unnecessarily. No. Then the understanding will not take place, sir. That is the idea.
Okay. Thank you.
So now, see, here I am looking at the significant value, right? It is 0.000, which is less than 0.05, which means there is a relationship. Matter over. Now, right? Always please remember, when you say there is a relationship, whenever you say there is a difference, you should not stop. You should explore. Okay. You should explore. Whenever you say there is a difference, who is having more, who is having less, that you should definitely you have to discuss. Definitely you have to discuss. No point in just telling they are associated, there is a difference. No use at all. We have to discuss how all these things. So now here we say there is a relationship. Whenever we say relationship, there are two types of relationship, right? So one is called a positive relationship, another is called a negative relationship. Now, what is positive is, what is relationship is, when one variable increases, one variable increasing, okay, one variable increases, when the other variable also increasing, that is called a positive relationship. One variable decrease, another variable also decrease. We call it as directly proportional, right? So when both variables move in the same direction, that is called positively related. When both variables move in a different direction, they are negatively correlated, right? So how to identify? So the correlation, the estimate is correlation coefficient, right? So yesterday we have seen the difference. The mean difference is the estimate, right? So here our estimate is the correlation coefficient, so which is small r. Okay, it is for a sample correlation small r. So population correlation rho, right? So here the r is small r is 0.811. All right. So which is positive, which means there is a positive relationship, right? So first point, we are trying to find out whether they are related. How we are trying to find out? We are performing, analyze, correlate, we are putting. Then looking at the significant value. When the significant value is less than 0.05, there is a relation. Right. So whenever we say there is a relation, we should not stop. We have to look at whether it is positive or negative. So now here we say there is a positive relationship. R value equal to, okay, you have to report R value as well as significant value, right? R value equal to 0.811, which is positive, which means there is a positive relationship. First, we are trying to find out relationship. Okay, we are trying to find out relationship. Whenever there is a relationship, we will look at the R value, we will say this one, right? So R is 0.811, which is positive. So there is a positive relationship. So now, what is the meaning of this R equal to 0.811, right? So I said there is a positive relation, right? 0.811, what is the meaning I am going to tell. So now let us look at the data. Let us look at the data. Now 8.81 is 80%, right? So now it means the 80% of the data moves in the same direction. Now, whenever we say there is a relation, all 100 data may not move in the same direction, right? Okay, majority of the data or significant number of data, we will say significant number, not majority, significant number of data moves in the same direction. That is the meaning. Now look at the values. Here it is 7, here it is 21, right? So now if you look at this value, okay, from 7 it is increasing to 12. Here also it is increasing to from 21 to 23. Here again there is an increase. Here again there is an increase. Here there is a fall. Here there is a fall. Now here there is a fall, but here there is a rise, right? Here there is a rise. So out of 5 values, 4 values moves in the same direction. 1 value, so 4 out of 5, so 80%. So now you see here it is a down, it is a down, right? So here there is a rise, here there is a rise. Okay, so like that it will go. So significant number or move in the same direction. That is the meaning of correlation. Very, very simple. Okay, look at the significant value. Okay, if it is less than 0.05, there is a relation. Look at the R value, right? If it is positive, there is a positive relationship. Right. Now, okay. Now I will go back. I will come back. I will go back to car sales. Now, okay. I will come back to this one later. Now, so I am taking car sales. Car sales. Earlier one, what I have performed. Okay, madam, cholunga. Where to go?
Analyze,
Analyze,
correlate,
correlate,
bivariate,
bivariate. Two variables put.
two variables.
Yes. Hmm.
Okay.
Now the significant value is right, madam. Yeah.
Significant value. That is a 0.837,
Hmm.
which is more than 0.05.
Hmm.
So there is no relationship.
There is
No relationship.
no relationship. Right. Very good. So now, anything you want to say further?
That is when there is no relationship, no need to check how that is whether it is positive or negative.
Very good, madam. Great answer. This is the answer I want. So see, people used to tell. I've seen many people what they have written. That is why I'm telling. Right. So they will say there is no relationship, and they will look at the R value. R value is minus. Then they will say there is a negative relationship. We cannot tell. When there is no relationship, there is no relationship. That's all. It cannot have positive or negative. Right. So now, okay. So now I will tell what do you mean by no relationship. What do you mean by no relationship? Right. So now, see, let us look at the null hypothesis. There is no significant relation between two variables, which means R equal to 0. The relation, that is the R. See, based on R only, we are determining the significant value. Always please remember, based on T value, significant value is coming. Based on high square value only, significant values are coming. But it is easy for us to decide 5% value. Okay, that is why we are going from the significant value. But significant value is the derivation of these estimates. So now, whenever we say there is no relationship, which means the correlation coefficient R equal to 0, that is the meaning. Whenever we say there is no relationship, the significant, the R value is 0, that is the meaning. Right. So, but R value, right? R value is 0, right? Now look at here. Okay, here R value is not 0. It is some value, but it is approximately equivalent to 0. Though you have some minus 0.0, not even 10%. It is 1.7% only. Very, very less. Right. So it is 0.017, which is very, very less. So which is approximately equivalent to 0. So it is not minus 0.1017. It is 0. That is the meaning. That is why we say there is no relationship. So that is why, but our null hypothesis is R equal to 0. That is our null hypothesis. Please understand, our null hypothesis is R equal to 0. But R is not equal to 0, approximately equivalent to 0. That is the meaning. That is why we say we are going to accept the null hypothesis. When you accept the null hypothesis, R equal to 0. But we will say there is no enough evidence to accept the null, reject the null hypothesis. We are not able to reject. We are not able to reject because the evidence, the R value is not that great, right? That is why we are not able to reject. So that is why we are accepting, right? So it is if you are a real gentleman, you have to write. There is no evidence to reject, right? For example, let us see how it is written. written here somewhere. Okay, somewhere written. Okay, leave it. Okay. There is, you have to write like that. Okay. Madam, is it okay or not okay, madam? Madam, okay, not okay?
Okay, sir.
Okay. So, okay. So, see, we cannot be first standard always. We should improve one stage by stage. Stage by stage. Okay. We should improve. We should not go back. So, see whether instead of accepting null hypothesis, how we have tried that we need to know. Right. Very good. So now this is what you have to write. Okay. So now I've explained what is R value, right? So now let us look at the formula for R, right? So this is the formula for R. Okay. So x minus x bar into y minus y bar divided by n. So that is the covariance. Standard deviation is x minus x bar square divided by n. So to estimate this correlation coefficient, look at the correlation coefficient. Madam, visible my screen?
Yes, sir, it is visible.
So R equal to covariance divided by standard deviation X, standard deviation Y. Right?
Yes, sir.
Okay. So now the covariance is this formula, standard deviation is this formula. So we are using the mean that you need to understand, right? So we will estimate the mean and we will try to find out how the variance is moving. That is the idea, covariance. So correlation is nothing but covariance divided by. So when this vary, whether how much this also vary. When we look at the variance x minus x bar, right? That we are doing. So that is why you have to use both variable metric, right? That is why you need to use both variable metric, right? Very good. Now, okay. So we will take up the one more correlation, right? So that is called a rank correlation, right? Rank correlation, right? We will take up rank correlation. Then we will come back, right? We will come back to, right? So now, okay. So I'm going to perform rank correlation. The data set is, it may not be visible, right? Because a new data set I'm opening. So now, this is gentleman has done a research on VRS scheme. Why they go for VRS? What are the motivating factors? So financial stability, limited career growth, enjoyment after retired life, deteriorating health condition, work fatigue. Okay, so like that, there are may 7 reasons are given. All these 7 reasons they are asked to rank, right? So since it is ranked, though it is not metric variable, we have rank correlation which is based on ordinal variable, right? Ordinal variable. So now, okay. So in see, we will say something, right? We will say something. We have to use only metric variable, right? When you have ordinal variable, what to do? This one correlation, right? So whenever you have used ranks, then you can use this rank correlation. Now, how to find out? Right? Analyze, correlate, bivariate. So we'll put all. We will put 2, right? We will put y on 2. So here for a rank correlation, you have to use Kendall or Spearman. Kendall or Spearman, right? You have to use Kendall or Spearman. That is the rank correlation. Okay, so now, so the significant value is 0.488, which is significant value I'm seeing. which is greater than 0.05, which means no relation, right? See, how to write interpretation when there is no relation? When it is the ordinary variable, we can say, right? When the sales, when you advertise more and more, the sales is increasing. When you put a more and more fertilizer, harvest is increasing. When you study more and more, marks is increasing, like that. Now here, based on variable, you should write. Now here, reason, right? Reason, right? Look at the values, okay, reason. So now look at the values. So reason one, what is the reason one? So reason one is financial stability, limited career growth, right? So, so already they are attained financial stability. So there is no relation, which means when this is increasing, this is not increasing. We cannot say when this is increasing, this is also increasing. What does it mean? Right. See, when they are given a higher rank here, right? Higher rank for this one, we cannot say they are given a similar kind of ranking for that also, right? So ranking given to this one is, and the ranking given to this one is not related. Okay, so for this one, they are given a different kind of ranking. So when the rank, when this is more, this is 3, this is also 4. When this is 4, this here one is rising, but here what happened? Okay, here rising, it is down, right? So like that, okay, these two reasons are moving in the same direction. Okay, so which means we can tell this is entirely different reason and this is different reason. People do not think these two reasons similar. That is the meaning. That is the meaning. So that way you have to write. Okay. So now this is called the rank correlation. The point is, whenever you want to perform the rank correlation, you have to use Kendall or Spearman. That is the point. All other things same. Right. When you can use rank correlation, when you are given a ranking variable, then you can use this rank correlation. Right. You can use this rank correlation. Right. See, now correlation is always bivariate. What do you mean by bivariate?
Two
Only
variables.
two variables, right? So when you have three variables, what will happen? When you have three variables, what will happen? What will happen? What will happen?
We calculate relationship between 192 and 2 and 3, sir. Or
Yes.
1 and 3.
Yes, sir. Yes, sir.
192, 2 and 3 and 193. Like that, we should calculate relationship.
So now I will take up, right? So I have many variables. I have many variables, right? What is this? Right, yeah.
What is that black stripe, sir? Why is this disturbing today?
So I cannot move, sir. This sharing the screen, participant, all these things we have to see, no, sir.
Okay.
So that will come, no, sir. For you also, it will be there, sir.
Yes, sir.
Mute, stop video, all these things will be there, no, sir. So this one is okay. So the enter the participants. This one is you want to see this. Okay. So always Hari na see. So they have raised the hand. So now
Harinakshi, Nandini, lower your hand.
Ha, sir.
Nandini madam has done.
No, sir.
Okay. So now okay. So okay. Let me not go away from the screen. So now I have okay. I have I'll close this one. Okay, necessity it is coming, right? So now analyze.
The screen is
Analyze.
not visible, sir.
Huh?
Screen is not visible. Please share it.
Okay, very good, sir. New now, sir. That may not be visible, sir.
Okay.
So
On. Okay, sir.
okay. Now I have many variables. Okay. So analyze correlation bivariate. Okay. So let me take three variable. One is gold price, GDP, and savings. Right. GDPS. Okay. I'm taking three variable: gold price, GDP, GDPS. Okay. Let me put it here. Okay. Let me say okay. Let me say okay. So now, so this is the output. Now I have taken three variable, right? So three variable means, right? I will have, okay, so I will have three people. Let us assume that three people, right? Three people. So now when I take two people, there will be one relationship between two. When I take three people, there will be a three relationship, right? A, B, C. A and B, B and C, A and C, like that. So when you increase the number variable, you will get many relationship. But the idea is correlation is only between two variable, right? Because the formula is covariance. Covariance divided by standard deviation, X standard deviation. So in the covariance, you can take only two variable, right? So now look at this one. Gold and GDP, they are related, right? 0.00, they are related. So gold and GDP, yes, they are related. They are related. Now, see, I have taken gold with the GDP, gold with the GDP, gold with the GDPS. Now I can find out GDP and GDPS. Look at this one. GDP and GDPS. They are also related. So there will be two diagonal. You can look at the top diagonal. That the bottom diagonal is the replicate of or duplicate of the top diagonal. Here, this also same, this also same, right? So when you take three variable, let us say gold, GDP, GDPS. Gold and GDP related, gold and GDPS related, GDP and GDPS, they are also related. So when you increase variables, we will find out many relationship, but correlation is always bivariate. Correlation is always bivariate. Correlation is always bivariate, right? Very good. Now, okay. So now I will take up the, see, for example, we have taken Narayanan, right? See, how for different purpose we can perform, I will tell. So the Narayanan data, what is that Narayanan data is Z score and H score. What is Z score is, see, for example, the finance students, they might be knowing. So it is the solvency estimate. For solvency, there are many models, Altman model, okay, Springate model, Fulmer model, like that. So this gentleman, he has used two models. This is Springate Z model and the Fulmer H model, right? So by using two models, he has estimated solvency score for how many companies he has estimated. So he has estimated a very good gentleman. So he has estimated for 124 companies, 124 NBFC actually here. So now he has estimated, right? So then suddenly he got some thinking. What is the thinking is, there are two models, right? But both models are estimating the solvency, right? See, when one model says the this bank is sufficient as solvent, other model cannot say it is insolvent. They cannot tell. Then there is a problem with models, right? So both model should predict in the same way. So whether both models are moving in the same direction or not, only for that purpose correlation is done. Look at how Okay, for what kind of application you can use. So when you know what it is doing, then you can apply for anything accordingly. You can write the interpretation accordingly. So that is why you should not simply write there is a related. Okay, you have to say there is a relationship, which means both models predict the scores are moving in the same direction, which means both models are predicting. One model gives higher score, another model is also giving a higher score. So which means both models are predicting in a similar way. So that way you have to write. Okay, so that is fine. Now I'm going for a partial correlation. I'm going for a partial correlation. See, what is this partial correlation? We are working in an environment. See, for example, there is a company performance. To improve the company performance, we might attend some task. But the performance is depending upon many variables, right? Many variables. Okay. So now let us take the specific example. We have two expenditure, advertising expenditure, sales promotion expenditure. Both expenditures are done to improve the sales. I want to know whether whether advertising expenditure is having a relationship with the sales or the sales promotion. If you do, see, for example, but look at sale is okay, only one variable. That sale might have happened because of advertising and because of sales promotion, right? So these two might have put the effort on impact on the sale. So if I want to find out the real relationship between the sales and the advertising expenses, I need to remove the effect of the sales promotion expenditure. So to find out the relationship between two variables, right? Relationship between one variable with the another variable, that should be removed, right? So sales promotion expenditure is also having related with car sales. Advertising also related with this one, right? I want to know the real relationship between advertising and sales. I should eliminate the effect of sales promotion on sales. So this is called the partial correlation. So controlling the effect, control, right? So whenever we want to find out the effect of this one, real effect of this one, we need to eliminate the effect of other one, right? So see, we might think that this gentleman is okay, so obeying just suddenly, right? Something else might have happened. That is why he might have obeyed. So what happened? That okay, so that you need to understand. Okay, so now let us go to the same gold price we will take. Okay, so here I have gold price. Now I'm going to put analyze, correlate, bivariate, right? So first let me put one by one. Okay, so now I have a gold price and GDP. Gold price and GDP. I'm putting only two variable, gold price and GDP. Right now, let us look at it. So they are related. 0.00 less than 0.05. They are related, right? So now let me go to the other one. Okay, so correlate, bivariate. Okay, so let me take another variable. So that is the money supply. Okay, so now earlier I have taken gold price and GDP. There was a relationship. Now I am doing with money supply, right? Money supply, gold price and money supply. Okay, so now, so this is also related, right? So less than 0.05, so related, 0.00, so related. So gold price, okay, and the GDP, they are related. Gold price, money supply, they are related, right? So now I know that GDP is the very, very effective variable. So now I want to have the relationship between gold price and the money supply controlling the effect of GDP. Okay, so analyze, correlate, bivariate, right? Bivariate. So now, not bivariate, I put a simply correlate, not analyze, correlate, partial correlation, right? I'm going for partial correlation. So now I'm going to put gold price and the money supply controlling the effect of GDP. Controlling the effect of GDP. Okay, so relationship between gold and money supply controlling the effect of GDP. Now, when we look, see, earlier we have seen money supply was related, GDP was related. Now, let us see what happened. Okay. So now, see, gold price and money supply is not related, 0.818. Okay, so which means, okay, when we remove the effect of GDP, then money supply is not related with the gold price. So because of GDP only, money supply has increased, right? Okay, so the effect of GDP is increased, money supply is not having any influence. So this is called the partial correlation, right? So this also you can use, but all variables should be metric. All variables should be metric. So controlling variable also should be metric, right? So we feel first we have seen the controlling variable should be related with that original variable, right? So that is why we are controlling effect of particular variable. So this is called the controlling. This is called the controlling, right? So now one more also we have one more data set. Okay, so this is carbon emission and life expectancy. So carbon emission, life. Okay, so now carbon emission in USA, carbon emission USA, life expectancy in China. All right. Okay, so now the so now let us put the correlation.
Excuse me, sir. Screen is not visible.
Screen not visible. Huh? So now, see, I'm going to take two variables. Look at the variables. So one is, okay, carbon emission in USA. Okay, this is a locked variable, right? Then life expectancy in China, right? Okay. Now let us see what happens, right? Correlation, right? Okay, so uh, so there is a very heavy relationship. Okay, very heavy relationship, right? But this is called the spurious relationship because how it is spurious we will tell later. So these two, see, this, after all, this is only package, right? It does not know carbon emission in US is different from life expectancy in China. It will not know. It is looking at the values. It is looking at the values and how the values are moving. It is performing calculating value and giving the result. So, but whenever you put any variable, okay, there should be some logic. Okay. So here I will not tell, okay, so how I can find out these periods, but when I go for a regression at that time I will tell. Okay. So, but what you need to remember is, okay, so whenever you put any metric variable you put, it will calculate and it will give. Even if you put category variable also, it will find out and it will give, but it is not good this one. Okay, so the mean is not good. So you have to use the appropriate variable, So that is the final thing I want to tell, right? So with this, the correlation is over. Now, if you have any doubt, anybody having any doubt, you can ask me. Madam Nandini, madam.
I am
So,
here, sir.
today I have not troubled you much, madam. Now, any doubt? So, Sandra Kumar sir, yeah.
Hello, sir. Thanks for the explanation once again, sir. Sir, I don't have much doubt, but my query is, are you covering ANOVA to some more extent?
ANOVA,
Latest?
yesterday we have taken civilly, no, sir.
Okay, sir. Okay, fine, sir.
No,
Fine.
no, I will take, but one way ANOVA I will not take again, sir, because yesterday we have taken.
Okay,
But,
sir.
there is some more ANOVA I will take up for tomorrow or day after tomorrow, sir.
Okay, sir. Thank you, sir. Thank you very much, sir.
Do you have any doubt on ANOVA, sir? Hello? Sandra Kumar, sir, do you have any doubt on ANOVA? Any
No,
doubt?
sir. No,
Huh?
no. I don't have much doubt, sir. Whatever is covered, I have understood, sir. Thank you, sir.
Very good. Thank you, sir. Thank you. So, Sudhishna Sarkar.
Good evening, sir. Am I audible, sir?
Yes, madam. Yes, madam.
Thank you, sir, for explaining correlation so nicely, sir. For the first time, actually, I've understood things so clearly, sir.
Very
Sir,
good,
one,
madam. Very good. Now you are good,
one
madam. Now,
doubt.
madam, Sudhishna Sarkar, madam. So,
Yes.
can you come with me when I go? I am troubling that, madam. Okay. If you can come with me, I can take along with me, madam. Right? Are you ready, madam?
Sir, actually, I am doubtful with that, sir. Sir, however, I have one doubt, sir.
Hmm.
Sir, in SPSS only I have seen that when we do correlation, the significant values are shown. But when we work with Excel and eViews, the significant values of correlation are not shown. So, sir, by looking at the value of R only, can we judge whether there is a significant relationship or not?
No, we can tell, madam. Otherwise, there is a formula also in Excel to calculate the significant value, madam. Right? So for chi-square also we can find out the significant value. For R also we can find out the significant value in the Excel itself. So that is point number one, right? But in chi-square or in T table, the significant value we can find out with the help of table also. But for correlation, we do not have any table, but we can calculate with Excel. Okay, so that is number one. Number two, all right. See, we are worried about the significant value. That is first point. Second point is, when you do not have significant value, by looking at the R value also we can find out, but I'm not very much comfortable with that. Why? Because see, for example, perfectly no relationship. When R value is 1, there is a perfect relationship. R value is 0, there is no relationship. Minus same, madam, minus same. 0, perfectly no relationship. 1 is perfectly there is a relationship, right? When R moves, okay, so 0.1, 0.2, 0.3, we will say there is no relationship only, right? So up to 0.5, we'll say there is no relationship. When it is more than 0.5, we will say there is a relationship, right? So that is with the help of R alone. But why I am telling I'm not comfortable, because, right? See, I do not have any. Okay. I will take up some data. Okay, I will take up some data. See, when your data is 1,000. When your data is 1,000 sample size, right? When your R is even 0.1, 0.2, I said if it is less than 0.5, there is no relationship. But when you have a large sample size, right, 1000, for example, 1000, then your R is 0.15 or 0.2. Then that time your significant value will be less than 0.05. So we will be telling there is a relationship, though R is 0.2. So the idea is when you have a, okay, see 1000 in 1000 data, 0.2 means 20%, which means 200 data. So when 200 data is related, it will say it is a significant number. That is why I've told you when there is a significant number, right? So it is not, I didn't say the majority, okay, moves in the same direction. So that is why I said significant number moves in the same direction. Then we will say there is a relationship. So the significant value is calculated by looking at the sample size, right? So sample size is a matter when we decide whether there is a significant relationship or not. Okay, so the sample size is matter. So that is why we cannot decide based on the R value. Now, for example, even when your sample is only 10, even when your R value is 0.7, okay, your significant value will be less than 0.0, greater than 0.05. Okay, so which means we will say there is no relation. Okay, so that is why by we are looking at R, we cannot tell they are related or not. Madam, is it okay, madam? Sudhish Sarkar, madam?
Sumita ma'am, next. Sumita P.
Madam, Sudhish Sarkar, madam, is it okay?
Hello.
Hello. Yes, sir, I was unable to unmute. Yes, sir, you have explained it very clearly, sir, because this is one thing which I've observed in many papers. Sometimes it is 0.7 and no significant relation. And
Yes.
sometimes it is 0.3 and there is
Yes,
significant.
yes,
And I
yes.
was very confused, sir. Today I got it all clear.
Yes, yes.
Thank you, sir.
Thank you.
Thank you so much.
Sumita P. Sumit P.
Sumita,
Sumita
okay.
Arumugam Raju.
Hi, sir. Good evening, sir.
Yes, sir, yes, sir.
Sir, can you explain the multiple correlation and partial correlation once again, please?
Though people used to say multiple correlation, okay, there is no one thing called a multiple correlation, sir. No. Okay, it is bivariate correlation only. Always correlation is between two only, sir, right? Though they will say multiple correlation, no multiple correlation, sir. Correlation is between two only, right? That is right. So whenever you have three variable, you will have three relationship because it is between two variable, right? So A, B, C. Let us, if you have three variable A, B, C, you will get one R value for A and B, one R value for B and C, one R value for A and C. Okay, so that is the correlation when you put multiple variables. Okay, so understood, sir? Multiple correlation. Hello? Arumam Raju, sir? Hello?
Yeah. Yes, sir. Yes, sir. I understood. What about the partial correlation, sir?
Partial, sir. Partial.
Yeah.
Partial. Partial is, so when you feel, right? When you feel, so when you take, see, we are taking many variables. Okay. So all the variables, we cannot say they are all independent each other. So some variable will be related, right? So to find out the real relationship between two variables, I want to control the effect of another variable, right? I have told you, no, advertisement and sales expenditure. See, for example, we used to say Okay, IIM people they are getting more employed, they are getting more knowledge. Is it because of they are studied in IIM? Already they have knowledge. Already they have knowledge. To find out whether the institute is having relationship with the knowledge important. So we should eliminate their earlier knowledge. So we should have conducted some examination. What is the score? What is the score of the people who have studied in other institute? Then you conduct now this test. Okay, this one, right? So now to find out relationship, that institute, that old marks, which is having the relationship with the new marks, that has to be eliminated. That has to be eliminated. Then only we can find out the relationship between these two variables, right? So the point is we are controlling the effect of one variable, one control variable, right? Controlling the effect of one variable, okay, to find on another variable, right? So we will find out relationship between two variables, for example, A and B, controlling the effect of C on these two. That is the partial correlation.
Okay, sir. Okay, sir. Thank you. Thank you very much, sir.
Now you can note, you might have noticed, sir, here, I have
Okay.
taken example. What example I have taken? Gold price, GDP related. Gold price, money supply related separately. Right. Then gold price, money supply, controlling the effect of GDP. I could not find out there is a relationship. No relationship.
Sumita P.
Okay. So if there is no doubt, I will go to regression. Right. Very good.
Sumita P. No, sir. No response. No, sir.
See, one more point is, right
Oh, please.
here.
Sumita.
Here.
Sir, am I audible now?
Yes, madam.
Sir, I have a doubt from the point where you have stopped the class, sir. You have spoke about the life expectancy of China and pollution in America, sir.
You do not
So,
know.
sir, no, sir. Similarly, suppose, sir, we have two different samples, sir. Suppose teachers and students. The teaching strategies of teachers and academic achievement of students, two different metric variables, sir. Can we correlate them, sir?
Madam, your question is really difficult question. See, two different data sets can be not be compared, madam. Two different data sets cannot be compared, right? So one data set you have collected from the students, one data set you have collected from the faculty, right, madam? So these
Okay,
two
sir.
cannot be combined. Why it cannot be combined? See, for example, you might have taken one teacher, right? Sivakumar sir is the teacher, right? One, okay. So one, right? So when you combine, what will happen? See, here, let us assume that this is the teacher variable, this is the student variable, right? So one, it is about the teacher Sivakumar sir. This student, it is not taught by Sivakumar sir, right? It might be taught by Nandini madam, right? How can you compare? Right. So if you have taken okay, when you have taken the same, okay, so this also about the same purpose, this student also about the same teacher, then you can compare, right? But normally we will not do that. So that is why you cannot compare.
Sir, in that case, what we can do, sir? What type of test can be performed? Like if you are taking suppose 5 teachers are there in the class, 5 different subjects, and the students in the class academic achievement can be find out, sir. Suppose I am taking 10 schools.
No,
So
wait.
10 into 4, 50 teachers and
No,
50 into 4.
very easy, madam. Very easy. See, for example, right? So you collect the data from the students, right? You collect the data from the students only. From the student, you ask which teacher taught you, right? Which teacher taught you, right? So they will tell the teacher, right? So then you find out the ANOVA, right? So teacher is a categorical variable. The marks scored by them is a metric variable, right? So the teachers, the students start by Sivakumar sir when they score more, and the teacher students start by some other faculty when they scored less mark. Then teacher is having influence on the mark. Simple. Hello, madam. Hello.
Yes, sir, I got it, sir.
Okay, so which means now their data set is students only, right? Students. From these students, you are collecting who is the faculty, right? Then only one data set, right? See, why I say it is right. This okay. Let me run a regression, right? Let me run a regression. So by taking life expectancy of the students here and the carbon emission of the faculty, carbon emission in China, right? I put statistics. Right. So now look at the R square value, right? So the R square value is 0.64654. Turbine Watson is 0.081, which means it is a spurious regression. When R square is greater than Turbine Watson, that is a spurious regression. That is what when you compare to, you should not do correlation, right? That is what it is proved. So that still I didn't teach the regression since the madam has asked. I'm just telling. So this is the same data, right? Carbon emission and the life expectancy, right? Okay, now let me go to the regression. Let me go to the regression. Okay, so now regression is used to find out the influence of one variable on the another variable. That is regression. Influence of one variable on the another variable. That is called the regression, right? So one variable influences the other variable, right? So the variable which is influencing, now all along we have not made any difference, right? Two variables. Now we are making a difference. How? The variable which influence is called independent variable. The variable which is influenced, we got influence, that we call it as dependent variable, right? See, for example, fertilizer applied, harvest, right? Then if you apply more and more fertilizer, harvest will improve. Why we are applying fertilizer? To improve the harvest. So which means we believe the fertilizer is having impact on the harvest. So the influence on the harvest, impact and influence same. So here the fertilizer is the independent variable, harvest is the dependent variable, right? So now we are having two variables. So first of all, we want to find out the influence of one variable on the another variable. That is the idea, right? Whenever we say influence, so one variable is influencing the other. The variable which is influencing, we call it as independent variable. The variable which got influenced, we call it as dependent variable. All right. So now we have two variable, right? Okay. So now you need to judge which is independent, which is dependent. That you need to judge. Okay. That is point number one. Then point number two, there should be logic and literature to say this is a dependent variable, this is an independent variable. Okay. Now my objective is to find out the influence of variable X. The independent variable, we call it as X. The dependent variable, we call it as Y. We want to find out the influence of X on Y. All right. So now, what is my null hypothesis? Nandini madam?
No influence.
No influence. No influence. That's all right. There is no, X is not influencing, right? So now the SAR has become expert how to fix the null hypothesis, right? So no influence, right? No influence, right? Sir, today I have forgotten, sir, when you talked only, I could remember the jokes. Sir. Normally I will give some example. Not
Sir,
today.
actually, so many chatting is there, sir. If you trouble Nandini, we learn more. Many
Okay, so now today I have talked too much of statistics. I have not given any example, right? So I
Nandini
will
ma'am.
okay for correlation. I will give example, madam. Madam,
Yes, sir.
for positive correlation and negative correlation, some examples shall I give, madam?
Okay, sir.
So you are not married, so please understand my example, madam. Right? So now before marriage, right? Before marriage, right? When you talk more and more, right? Before marriage, when you talk more and more, love will develop, right? But after marriage, when you talk more and more, right? So only the love will not develop. Only what will happen? So this will
Yeah.
relationship will break. So you should not talk much. Okay, it is not for girls, it is for Sivakumar sir. Okay, only after marriage, only limited talk should be there, right? So, okay, talk is more, relationship will come down, right? But before marriage, okay, so positive relationship. When you talk more and more relationship, right, madam?
Okay, sir.
So before marriage, when you talk more and more, okay, love will develop more and more. Okay, very good. So now we will go for regression, right? I said null hypothesis, there is no relationship, no influence. Okay, so now I will take up the data set. I have limited only. So in the regression, I will be talking more and more, right? So now today I will teach regression. Okay, so please, I will send the data set also. When you come tomorrow, I will teach again regression. Okay, so please understand and come, because regression is very difficult to understand. I will be talking more and more advanced thing in regression, because regression is a very, very difficult subject. Okay, it is not like correlation, right? So now let me take two variable. Okay, so now madam, I have
No, sir, not visible. Waiting.
not visible, right?
Visible, sir.
Now I have two variable. Yes or no?
Yes, sir.
Okay, so now we got to tell
Total income.
what is the type of variable, madam?
Metric.
Metric.
Oh, madam.
Income is also metric, saving is also.
Okay, madam. How do you say both are metric, madam? Sir is telling, you are telling her.
No, sir.
Ah,
Values are none, no, sir.
very good. The first point is very clear, right? Okay. Okay, so now madam is our no. Okay, so understood how to understand very easily. That is important. Easy way of understanding that we need to have. Okay, so the second point is it put a scale, right?
Okay.
Okay, now the third point is look at this one 44,000, 22,000, 50,000 like this.
Okay.
Can we find out frequency? We cannot find out frequency, right? So because values repeated is very, very less. So when you do frequency, we'll take 144, 122, 150 like that you'll get. So no point. So we can find out the average, right? So both are metric variable. So when both are metric variable, we can do regression, right? But we will change, yeah, we will tell some condition, right? When the conditions we could break, we can find out, we have alternate, we have many alternate, right? Many alternate. So I have told you ANOVA, see the homogeneity of variance should be there, but when there is no homogeneity, we have a test, right? Like that, we have many other things, okay, to But because we are in the software environment, we have many robust techniques. Only thing is you need to know. You need to know, right? So, madam, okay. So I have taken two variable, madam. Right. Very good. Right. So both are metric. Then I can do regression. Right. Now analyze regression. Analyze regression. Linear. Analyze regression.
Linear.
Linear. Right. So now I have two variables, saving and income. Which
Okay.
is the dependent variable, madam?
Savings.
Income. Hey, income.
Madam,
Sorry.
Income.
no, savings is the dependent variable, right?
Yes, sir. Income is
மேடம் வந்து சார் எக்கனாமிக்ஸ்ல எக்ஸ்பர்ட் அவங்க.
independent.
So now, okay. So now, madam, okay, you have to look at the coefficient. Okay, coefficient. Yeah. Yes. Okay, so we want to find out what is our objective, madam. What is our objective? We want to find out whether
Influence or not.
income is influencing the
Yes, sir.
saving.
Sir.
Yes. So we want to find out income is influencing the saving. Yeah. Now what you have to see? Now the significant value is 0.00, which means income is influencing the saving. Simple. Right? Less than 0.05 means there is an influence. Simple, madam.
Sir.
Madam. So no confusion. Very, very simple. Right? Very good. So 0.1 is over. Right? So our objective is to find out whether income is influencing the saving. All right. We have seen. Okay. Income is influencing the savings. Right. Very good. Now. Right. So when it is less than 0.05, there is an influence. Right?
Sir.
Okay. Very good. Now here we have a t value. Right? Can you see the t value?
Yes, sir.
Yeah. T value is 10.351. Tell the rule.
When it is less than 1, no, sir.
Yes, madam.
When it is less than 1.96.
Madam, இதுக்கு தான் less than. இதுக்கு என்ன?
More than.
When it is more than. More than 1.96.
நீங்க அத okay. So this I have told you know when t increases, significant value will come down, right?
Yes.
Okay. So when t is more than 1.96, which means there is an influence, right? We have to reject the null hypothesis, right? The same process. Okay. Okay, very good. So point number 1, when the significant value is less than 0.05, there is an influence. Otherwise, when the t value is more than 1.96, there is an influence. Same thing, same, everywhere same, right? Very good. Now, right, now, how to find out the t value, right? So now what is the formula for t value, madam? T value is equal to estimate divided by, சொல்லுங்க madam, what is t?
Standard error.
Good madam, good, right. So very good madam. Okay, so if mind la you have put many things, mind வெடிச்சிர போது பாத்துக்கங்க. Okay, so okay, so estimate divided by standard error is the t value, right? Very good. Now here see the estimate will be different in different place. Now in a correlation, estimate is R. In ANOVA, estimate is difference. Now here the estimate is beta. Now this is the beta. All right. See, you can see here 0.161 divided by 0.016, which is equal to 10. 0.16 divided by 0.016, which is equal to 10. Okay. So t value equal to, you can write it down, t value is equal to unstandardized beta divided by standard error, which is equal to t value.
Please repeat, sir.
Right, madam? Okay.
Repeat, sir.
Repeat, sir.
Here unstandardized beta, here beta value
Okay.
0.161. So look at the column name unstandardized, B is beta. Divided by standard error 0.016, which is equal to 10. Okay, now over. Okay, so now, so, okay, so now I have to teach two important things, two very important things. Okay, so what is that? There are many regression, right? The screen.
Not visible.
Opening. Sir. PPT short screen, sir.
So there are many regression, right? Like this. Okay. Okay. To find out the influence of one variable on the another variable, right? Okay, like this. Now, the regression equation is y equal to a plus bx. Regression equation is y equal to a plus bx. I have written y equal
sir.
to a plus bx. Now, what is y? It is a variable, right? What you can take any variable, dependent variable, right? X is an independent variable. Some variable, some value variable mean it will change, right? Very good. What is variable? Well, the values will change. Values will change, right? So now, okay. So X and Y are variable, right? So now we need to know what is A and B. A and B. To understand A and B, right? To understand A and B, right? Let us try to understand a few things. A, right? In this equation, when X is 0, this X is 0, B into X, this will be 0. B into X, which will be beta into 0, which is equal to 0. So then what will happen? When Bx is 0, Y is equal to A. Otherwise, when X is 0, Y is equal to A. Right. Very good. So now we will try to understand. When X is equal to 0 in this, right? So when X is equal to 0, let me make it little big. So now here the X is 0. X is 0 this point, right? X axis is 0. So now this is the regression line. Y is equal to A plus Bx line. Linear line, straight line. Right. So now, see, when X is equal to, this is the line, this point. When X is equal to this, Y is equal to this level. When X is equal to this, Y is equal to this. So when X is equal to this, Y is equal to this. Right. So when X is 0, Y is equal to A, this point. This is the point. So here, this point is equal to 0, comma A. Right. So now, okay. So now what is the point A? What is the special about that point? All are points. Okay. These are all points, but there is a significance in this point. So this point is a point of intersection. Point of intersection. Otherwise, right, at the point of A, the regression line, this is the regression line, intersect the y-axis. right? At the point of A, the regression line is intersecting the y-axis. So that is why A is called intercept. Intercept. A is called intercept. Right. What is the meaning of A? Right. When x is 0, which means x is nothing. But even then, y is equal to some value. Otherwise, see, for example, when you study more and more, we say you will get more and more marks. So x is number of hours studied. Y is what is the mark you have scored. All right. See what will happen. Even when you have not studied anything, you will get some marks. That is E. Number of hours studied is x-axis, x. Right. When number of hours studied is 0, even then you will get something that is A. Y is equal to A. That is the A. So irrespective of x is 0, you will get something. Okay. See, for example, even without applying fertilizer, you will get some harvest. Even without taking any risk, you will get some return, risk-free return. That is A. That is A. Right. So even nothing X, you will get some Y. Y is equal to A. Right. So now I will go to the another point now to explain beta. B. Right. So the understanding beta is very, very important. Beta is very, very important. A is not that important. B is very, very vital. Now to explain beta, let me take some more examples, some more assumption, right? Now here, okay, this is the equation. Now let us assume that beta is equal to 2, B is equal to 2, A is equal to 5. Some assumption. Let us assume that, okay, we have run a regression. We got A is equal to 5, B is equal to 2, some values. Then, okay, A is equal to 5, B is equal to 2. Suppose if X is 10, what will happen? X is 10, what will happen? Y equal to A is 5 plus beta is 2, X is 10, right? So now 5 plus 2 into 10, 2 into 10, 20 plus 5, 25. So when X is 10, Y is equal to 25. Right? Very good. Now, let me increase X by 1, which means already X is 10, right? Now I am increasing X by 1. So which means X has become 11. Okay. Then what will happen? So Y is equal to 5 plus 2 into 11, okay, 22 plus 5, 27. When X is equal to 10, 25. When X is equal to 11, 27, right? Otherwise, when I have increased X by 1, Y has increased by 2, right? X of 10 to 11, this is 25 to 27, 2. Okay, so why it is 2? Because beta is 2, right? Beta is 2, right? So which means beta is 2. That is why when X is increasing by 1, Y is increasing by 2. All right. So if beta is 0.5, what will happen? When X is increasing by 1, Y will increase by 0.5. So what is beta? beta is when there is a 1 unit increase in x. When there is a 1 unit increase in x, what will happen in y? That is beta. That is beta. Okay. Now, right. See, I can tell when x is one increases, that will increase by 2 times. 2 times when beta is 2. So, beta explains the extent of influence of x on y. Or what extent it will increase. What extent it will increase. So, the purpose of regression is not only to find out whether there is an influence or not, we can find out the extent of influence also. So based on beta, we can find out the extent of influence of x on y. So the beta explains the basic purpose of regression. What is the purpose of regression? To find out the extent of influence. So you are getting answer for the regression in the beta. What is the regression? To find out the extent of influence. How do you find out? Based on beta. So beta, we call it as the regression coefficient. Call it as regression coefficient. Otherwise, we will call it as slope. When there is a 1 unit increase here, how much increasing? So the slope is dy by dx. Look at this one, when d 10, 11. So this increases from 25 to 27. So beta is dy by dx. What is different? What is dy? Difference in y 2 divided by difference in x. Dy by dx calculus. So 2 by 1, which is equal to 2. So beta is the beta is the slope. Beta is the slope. Okay. So now we know what is A and B. Now what I have explained is, now here this is the A value constant or the intercept. This is the A value. Here our A value, our independent variable is income, dependent variable is saving, right? Y is savings, X is income. My A value is 3,281. My beta value is 0.161. Right. So with this equation, with this coefficient means before we can write the regression. So y equal to, now you can write it down, y equal to 3,281 plus b 0.161 y. Now let x. Now let us substitute y. Y equal to savings. Savings equal to 3,281 plus 0.161 into income. Hello? Hello? Hello, madam? Hello, madam? Madam,
Sir?
are you there, madam, or gone?
Yes, sir. I am here, sir. I am here.
Okay. So, have you written the regression equation, madam?
Sir, that I missed.
Yes, madam?
Yes, sir. Written y is equal to a plus bx.
Ah.
Oh, correct, sir.
Read, sir.
Y is equal to A plus BX.
That is old, sir. With the help of this one, I have asked you to write, no, sir. Hello.
Yes, sir. Written, sir.
What is Y? Savings equal to, I have written, I have told you, no, sir. Saving is equal to 3,281
Plus 0.161.
into income. Y, X is income. Yes or no?
Yes, sir.
Now, if you give the income value, right? If you give the income value, some, for example, 10,000, can you find out savings? Because savings is 3,281 plus 0.161 into income. Yes or no? Hello?
Sir.
No, madam, if you give the income, can you find out savings or not, madam?
Yes, sir.
Yes. So that is why regression, we call it as estimation technique. That is why we call regression as a forecasting technique. When you have this equation, okay, saving is equal to 3,281 plus 0.161 into income. When some people, they give their income, we can predict their savings. Right. So that is why regression, we call it as prediction technique. So we use for all purpose, all are regression only. All are regression. For example, structural equation model, it is regression. In in commerce, we will use many things like Arima, Kache, panel, all are regression only. All are regression only. Okay. So because we want to predict, we want to estimate, so we use the regression. Okay. So now we have learned how to write the equation, right? Okay. So I think with this we will stop. Okay. So now if you have any doubt, so I have many things to say, that and all I will come later. I have many things to say. Yeah. Many more things to say. Yes.
Chandra Kumar. Chandra
Hello,
Kumar.
sir. Hello, sir. Yeah, yes, sir.
Yeah.
So thanks for the explanation, sir. With the regression itself, we can find the influence. So is there a need to go for correlation?
Sir, okay. Correlation is to find out relations, sir, right?
Yes.
Regression is used to find out influence. So that is the point one.
Yes.
Right. Point two is right. Okay. So now this is the another regression equation, sir. Right. Can you see my screen, sir? Screen visible,
Yes, sir.
sir?
Yes, sir.
Yeah.
Visible. Data
Now
set.
y minus y bar is equal to r into sigma y divided by sigma x. Right. Okay. So this is my y on x formula. So y minus y bar equal to r into sigma y divided by sigma x into x minus x bar. Right. So now see, from this is the y on x formula. Now from this you can find out, you can infer two things. First of all, see here x bar, which means mean, y bar, which means mean, right? Standard deviation. What is standard deviation? Right? Standard deviation is x minus x bar square. Okay. Divided sigma divided by n square root. So there also we are trying to find out mean. So standard deviation is deviation from the mean. So we will estimate mean. We have already told you R is correlation. R is correlation. Correlation also we can find out only when there is a metric variable. So from this we can understand. So we are using mean. Okay, not one mean. Here also we are trying to find out mean. Here also we are trying to find out mean. For standard deviation also we are trying to find out mean. For R also we are trying to find out mean. So we are estimating mean many times. Okay, we are estimating bar many times. When you perform regression, You are in the bar always. Okay, bar like kadakringa, right? So we should use only when the variables are metric. That is the point number 1. Point number 2, look at the formula R into R is correlation, right? Okay, R into, when correlation is not there, when there is no relation, then definitely we can tell that variable will not influence. So the regression is depending on the correlation, R square. That is R square, R order square, right? So now, when there is no relation, definitely there is no influence, right? Some people, they will put a correlation. After that, they will put regression, right? See, definitely you will get no influence only. You cannot get, never possible. When there is no relation, you cannot get influence at all, right? So correlation and regressions are, okay, similar technique. In fact, regression, it depends upon the correlation. Hello, sir.
Yes, sir. Yeah, thank you, sir.
Next question. Pala Sarika. Pala Sasikala.
Palla Sasigala,
Palla Sasikala.
Andhra Pradesh.
Palla Sasikala.
Madam.
Sir?
Yeah, Palla Sasigala, madam, tell.
No, sir.
Yes.
Hello,
Madam.
good evening, sir.
Good evening, madam.
Sir, one variable is a organizational climate, sir.
Tell.
Hello. Second variable is occupational stress, sir. When we go for regression, sir, or correlation, sir, and
See,
the
find
influence.
out- No. Wow. See, first you find out correlation, right?
Okay.
So that will tell
Okay,
there is whether they are related. Then you find out the regression.
Okay.
Regression will tell the whether there is a influence or not, right? First,
Influence or not.
don't put the
Okay.
first regression, then don't put the correlation.
Okay.
Next is
Okay, sir. Thank you, sir.
Sarkar. Sarkar.
Hello, sir. Hello, sir. I'm Devrat Sarkar from Chhattisgarh. I'm a research scholar. Sir, I have a doubt. Sir, I having pre-test and post-test data, as well as in my study, 2 research group is there. Experimental group is there and 1 control group. So which statistics I should apply?
That you have to understand based on my teaching, sir.
Yes, sir.
Listen carefully, then okay, try to judge. So what you can apply.
Researchers, please ask question related to SPSS. Please don't ask your PhD questions.
Sir, actually, in my study, I have been applied ANCOVA. So now I am facing like as T-test or ANOVA.
Okay, next question.
Sir, please understand, sir. See,
Yes, sir.
I can give the idea, no issue at all. But
Yes, sir.
I have to look at the data, how, what you are telling. Okay, I have to apply my mind. Then I have to tell. Just like that, no prescription, sir. I have to diagnose and I have to prescribe, sir.
Okay. Sakshi.
Sir, actually, my question is not related with that much SPSS, but my question is related with my study. Is this possible that you give me the answer? Because I am in the big dilemma and my synopses are really. Sir, my question is really very simple, that whenever we are going to prove a relationship between 2 variables, we have to first of all find the literature regarding that. But sometimes, sir, we find, for example, if we find the word AI adoption, but instead of that, there are so many papers on AI capability or IT capability or IT adoption, can we take in exchange of all these variables or not? At the time of defending, we can defend it like artificial intelligence and IT means information technology. We can use the interchangeable words or not for for proving any relationship.
That only the researcher can do, no, madam. What you have measured, whether a AI is okay, so whether it is related, whether it is similar, whether it is different, that only the subject expert can do. The researcher is the subject expert. So as a statistics expert, so when you show the data, so this is the data, sir, what, whether I have performed this test, whether it is right or wrong, I can tell. So for example, when you say whether this is the categorical variables or this is the metric variables are, so what test I can apply, like that I can tell, right? So whether the variables are same or not, how can I tell, madam?
Sir, if there are so many literature review, but in some papers it told it like AI adoption, and in some papers it talked about IT adoption. All these we have to defend that IT
No,
means
no,
AI
madam. No.
technology
Okay,
that
so
we
but
can.
now, madam, see, I can give answer to all, right? There is no doubt about it. So that gentleman has asked, I can apply mind, I can give no problem. But please understand, AI is not simply IT adoption, madam. AI is something, okay, something more than the IT. See, for example, see, in our university, we have adopted, see, for example, legal application, okay, or messages, all are now, earlier people used to come and give the circular. Now circular and all online, leave application online, the for PhD thesis submission online, evaluation online. So we have applied the information technology, but we have never used the AI. AI is something different, something extra.
So it means we have to find just the same words. AI adoption means AI adoption in every relationship.
Yes, ma'am. Yes. Say yes, ma'am. Information technology is very ordinary. Now it is there everywhere. But the AI adoption is, see, for example, the AI adoption is, for example, when you talk about the agriculture.
Sir, please unmute, sir.
So that is the AI. So AI is the regression only, but based on, okay, so all the earlier inputs. So it will develop the module, it will develop the neurons, it will develop something, so to predict. So AI is a prediction technique. So AI is a prediction technique, but information technology is the information technique. Hello?
Okay, okay. Participants, there is a one information. The feedback is already posted in the chat box. I request before leave this meeting, please copy the feedback link. Please submit it. It will be closed after 1 hour. Okay. The management decided that only to issue certificate for active participation. Therefore, we will stop to 400 to 450 certificates. So please submit this certificate, because active participation, sir also knows that 350, 400, 420. Okay. Therefore, please submit the feedback form within 1 hour. It will be closed after 1 hour. Thank you. Nandini, please conclude the session, today's session. Over to you, Nandini.
Yes, sir. Yes, sir. A very good evening to one and all once again. It's my immense pleasure to run the vote of thanks for Day6. On behalf of Sheshadripuram Educational Trust, I would like to extend my heartfelt thanks to our resource person, Dr. R. Kasalingam, sir, for his wonderful explanation on correlation and partial correlation and regression in today's class. In today's session. Thank you so much for sharing your knowledge towards this wonderful topic. Thank you, sir, once again.
So one request is, many people what they do is So they attend immediately, they will try to correlate with their literature, right? So that you do after going home. Now itself, if we start thinking, you will not understand what I am telling. So try to capture, okay, whatever I am telling and try to understand whatever I am telling. Then after understanding, then go home, apply whether it can be used for your literature. So for your study, when you are listening itself, that time itself, when you think about this one, then you will not you will not, your mind will not go beyond certain point. Your mind will not go beyond certain point. Okay, so listen carefully, try to understand each and everything. Everything will give some meaning to it, some meaning to it, right? Okay. So, but I can give a solution to all problem. Okay, all these things. But when I talk about only one individual, why we are not taking the research question is, see, when I talk to one madam, other people will be simply sitting. Other people, it is not related. So that is why we are not taking the any research related question. But the when we have to give solution to all, that is the story. That is the story. Then only your purpose will be solved. Then only your purpose will be solved. But you try to think, then definitely you will get a solution on your own. Okay. So thank you, sir. Thank you.
Sir, you better to start on the research solution online, sir, like liar.
See, sir, see, the matter is, sir, I have evaluated around 120 thesis, sir. For every thesis, I am writing 10 pages, 12 pages by taking 4 or 5 days. So that they will teach. Whenever I go for Viva's examination, there also I am telling. Whenever I go for anything, I am telling. But no learning is taking place, sir. No learning is taking place. The people are having the concern of to send the research thesis without the statement of problem, without the research cap. So that is the trend, sir.
Okay.
Okay, thank you, sir. Thank you so much, sir.
Thank you, one and all. Please submit the feedback form within 1 hour. It will close. Thank you. Thank you very much.